I am Anil Kumar. Welcome to my video on polynomial expressions. We'll discuss common factors in this particular video. This video is excellent for all those who are beginning to learn factoring, so it can give you a great foundation. We'll discuss basic concepts of factoring, greatest common factors, which are also known as the highest common factors in polynomials. We'll model to visualize factoring, monomial common factors, binomial common factors, factor by grouping, and some practice test questions will be taken. There are 12 questions in this particular video which can help you master the techniques for factoring and group factoring. So let's begin from the very basic concepts. So you have learned already about expanding. Let me take a simple example here to expand a polynomial. Let's say we have 2x times x plus 1. Now if I multiply, what do I get? 2x times x, we get 2x squared, and then with 1. So we just multiply. This is called the distributive property, and what we get here is 2x squared plus 2x, right? Now that is expansion. Now coming backwards, which is from the expanded form back to this, is what we call factoring. Perfect. So factoring is to write as a product. So in expansion, what we do here, we write as sum or difference. And here, while moving towards factoring, we write as a product. So that is the very basic concept with which let's move forward. Now we'll talk about the greatest common factors. You have learned already in arithmetic how do you find greatest common factors. We'll extend that to polynomials. Sometimes we also refer this to HCF, which is highest common factor, one and the same thing. The question here is find the greatest common factor of each of the following. So we have two terms. So it's a binomial, and 6x cubed, let me rewrite this. We have 6x cubed and we have 9x squared. So these are the two terms, right? So what we call them as two terms. So these are the terms. Now let's write down the factors for these terms. So when you want to write the factors, 6 could be written as 2 times 3, and x could be written as x, and x cubed, that is, right? 9 could be written as 3 times 3 and x times x. If you look for common factors, you find that the 3's are common, these x's are common, these x's are also common. And therefore, now we could actually write down the greatest common factor or the highest common factor, as you may call it, by the product of the common factors, right? So the product of common factors here, in this case, will be 3x squared. So it is 3x squared, which is the greatest common factor. We basically multiplied these three to get our answer, which is 3x squared, right? So I hope you get it. So it is 3 times x, which gives us 3x squared. And that is the way to find the greatest common factor. Let us take up another example before moving forward. So this time we have two terms which are 7 cubed x to the power of 5 and z. The other one is 7 squared x squared and y. Now what are the common factors? First, let's list the factors themselves. So if you list the factors, 7 cubed means 7 times 7 times 7. X to the power of 5 means there are 5 of these, right? And then 1z. For the other one, we have 7 times 7, x squared and y. So let's see which are the common factors. So of course you get this group of 7s as common and this group of x as common. Now we'll just multiply these. So we have a common factor which is 7 times 7 times x, or you could write this as 49 x squared, and that is the way to get the common factors. Perfect. So I hope this strategy of writing the highest common factor or the greatest common factor is absolutely clear. Now let's use this facility of let's use this technique in factoring. Well, before that, let's look into how to model or visualize factoring. We used algebraic tiles earlier to expand, that is to multiply the polynomials. In this case, we'll see the reverse process. So the question for you is, use algebra tiles to factor x squared minus 3x. Now, how can we do that? Well, x square means we're looking for 1 square, and that is x square, right? 3x means these are your 3x's. That is how we have our tiles here, 3x's. Now, how can I use algebra tiles to factor? Well, I have to figure out what could be the two terms multiplying to get this. Well, one could be x, and that is 3, right? And on this side, I can place another x. So that gives you two different factors. So now I can write my answer, which is x times x plus 3. Does it make sense to you? So that is what it is. That is how we could actually factor this. So this is called the factored terms because we are getting the product, and that was the expanded form. So we have utilized the algebra tiles to get the factored form, right? I hope that makes sense. Let's take up more examples, and this time we'll look into binomial model. So this time we look into a model to visualize again, which is using algebra tiles to factor. We have 2x squared and 4x. Well, how am I going to do that? I'd like you to pause the video at this stage and figure this out. So what we have here is two of these x squares, okay, and we have four of these x's. So if I have four of these x's, can I form a rectangle? That's the whole idea. Well, I could arrange like this. Does it make sense to you? So you might need some practice to arrange them in an order so that that can make sense and fit into a rectangle. Well, this rectangle will have one x and 2 units, right? So 1x and 2 units. On this side, we have 2 x's. That makes sense. So we could write this as 2x times x plus 2. So that becomes the factored form. Does make sense to you? Let us check our result. So this time we are going to check it. So we'll apply the distributive property, multiply, and see whether we get our original equation or not. 2x times x is 2x squared, and when you multiply 2x by 2, you get 4x. Well, that makes sense. This is where we started from. So you do have the same result, and that means both are equivalent forms. So we got a factored form from sum and product, and that is what factoring is. And that is how you can visualize the result using algebra tiles. Perfect. Now let's do some factoring finally. So we know our tools now, what to work with and what everything is called. Now we'll do monomial common factors. Factor fully if possible. Now this is important to understand. When we say factor fully if possible, that gives us something to think about, that it may not be possible to factor always, right? So let's write down. It may not be possible to factor sometimes. That makes sense? Okay, so that is what it is. Well, what could be the case? Let us say if I say 2x plus 3, well, there's nothing common in between them, so you cannot factor. Perfect. So that is an example which cannot be factored further. So we could have that kind of a situation. Okay, now let's get into solving the questions given to us. We are now looking into factoring 2x cubed. So what we have here is, let me rewrite this. We have 2 cubed a to the power of 4 minus 4 square a square b. That's tricky. So what is 2 cube and what is 4 square? Well, it's better to rewrite this. 2 cube is 8 and then we have a to the power of 4 minus 16. 4 square is 16 a square b. And now we can see that we do have a common factor here. It could be divided by 8, both of them. So 8 is a common factor. We're looking for greatest common factor. And amongst a's, we have two of them. And once you do that, you're left with a square on this side and minus 2b. So that becomes the factored form, a bit tricky. So as we move along, we'll have very interesting examples here. So I hope you're going to enjoy it and learn. These are actual test questions which you don't see in books. Now here we have a fraction part, question number 6. You need to factor 1 by 6x cubed minus 2 by 3xy plus 5 by 9 xy square. Let's rewrite this. So I'll write this as 1 over 6 x cubed minus 2 over 3 xy plus 5 over 9 xy squared. What do you think is common between the numbers? Well, 1 over 3 seems to be common, so we'll take that as a common factor. Now, to write the numbers which come as the coefficient of these variables, we have to divide them by 1/3. That is as good as multiplying by 3, right? Okay, so what you could think about 1 over 6 as product of? Let me rewrite here on the side. 1 over 6 could be written as 1 over 3 times 1 over 2, correct? So definitely 1 over 2 remains when I get 1 over 3 outside. Or you could also think about like this. 1 over 6 times 3, and that reduces to 1 over 2. So dividing by a fraction means multiplying by a number, right? So we'll multiply these by 3 and get a result. So in the first case, we get half x. Now x, 1x is common, so we can take x as common. That's fine, nothing else. So let me take x common outside. That means, okay, so we have 1/3 of x common. And what we get inside is half of x squared. And here 1/3 is common, so 2y is remaining, 2y. We have already taken 1x common. Now in this case also x has been taken common, and we get plus 5 over 3. 3 times 3 is 9, y squared. So that becomes the factored form. Does it make sense to you? Have a good look at it. So this kind of a question could be in your test. Now let's move forward and take another example. Example number 7. Binomial common factor. Question number 7 is 3x times y plus 5 plus 6 times 5 plus y. So what we will do here is, nothing seems to be common in the brackets, but there is 3x and 6. Yes, 3 is common. Let me rewrite this and then we'll look into the factors. I'll write this as 3x y plus 5 and the other term as 6 times y plus 5. Now you see more factors. The idea here is to get the greatest common factor out. So 3 is definitely there, which we can take out, and the term y plus 5, that is also common. When you get that common factor and dividing the first term, we are left with x, and the second term we are left with 6 divided by 3, which is 2. So that becomes the solution. Does it make sense to you? So that is how we are going to get the binomial factors. Now the next example here is 3 times p minus 1 whole square plus 12 times p minus 1. Let me rewrite this in a different way. So we can say it is 3 times p minus 1 times p minus 1, right? So that is the meaning of square term. As far as 12 is concerned, we could write this as the product of 3 and 4, and we have p minus 1. So I made it absolutely clear. As to now, you can clearly see what is the greatest common factor. P minus 1, of course, is a common factor, and also 3 is a common factor. And therefore, we are going to take 3 times p minus 1 as the greatest common factor. We are left with p minus 1 in the first term and plus 4 in the second term. We need to now combine this to simplify and write the final result. So 4 minus 1 is 3 plus. Okay, so that becomes your solution. Does make sense to you? So sometimes, even after factoring, you may have to simplify and write down your answers. Let's move on and take question number 9, which is factor by grouping. This time we have 4 terms. Okay, let's write down these terms, which are axy plus ay plus 3x plus 3y. Now, what we should do whenever we have 4 terms, we have to group them. So we have 2 groups here, and clearly in each group we can find common factors. A and y is a common factor in the first group, giving us x plus 1. And in the second group, 3 is a common factor, right? So if I take 3 as a common factor, in that case, I get x plus y. Perfect. So that is not giving us any particular result. So in this particular case, we took uh, the common factors, but we find that there is nothing common which could help us factorize. Does make sense to you, right? So we did ay, left with x plus 1. In this case, we factored 3, but we got x plus y. So this is not factorable. Is that clear to you? So there could be times when you get a question which is not factorable. So a good thing could have been if possible. Is that clear to you? Let me just modify this question so that you could actually factor it. So the new question for you is axy plus ay square plus 3x plus 3y. So if I have this as your question, in that case, you can factor it. Perfect. So let this be your test question. Is that clear to you? So you can factor this particular uh, polynomial and then get the result. Now let's move on and take question number 10, which is 1 plus xy plus x plus y. Now how am I going to factor this one? Let's rewrite this. We have 1 plus xy plus x plus y. Well, one thing is there, we could rearrange, right? So if I rearrange, taking those y terms on the other side, we could write this as equal to 1 plus x plus y plus xy. Now, I have here 1 plus x, and on this side, I can take y common, which will give me 1 plus x. Now you can see that 1 plus x is a common factor. And finally, we could write this as 1 plus x, group them together, 1 plus y as your answer. Does make sense to you? So as you can see, group factoring can be very tricky. Pause for a minute and look at it before moving on to the real test questions. Now question number 11 and 12 are the test questions for you. Now here, question number 11 is 2 times 5 minus y plus 6 times y minus 5. You need to factor this, right? So it's practice test question to factor if possible. You can pause the video, answer this question, and then look into my suggestions. Okay. Now let's begin. We are given 2 times 5 minus y plus 6 times y minus 5. Well, as far numbers are concerned, we could factor 2's, no problem. But as far as the terms are concerned, can we factor this? Well, of course we can. If I interchange, then look here. I could write this as 2 times 5 minus y. And if I take minus common, in that case, this becomes minus y plus 5, which could be treated as 2 times 5 minus y minus 6 times also 5 minus y. So as you can see now, 5 minus y is a common factor. And as far as the numbers are concerned, 2 is a common factor. So 2 times 5 minus y is common, and we get 1 minus. Here, dividing 6 by 2 is 3. So we get 1 minus 3 here. And that could be written as 2 times 5 minus y, and that is 1 minus 3 is minus 2. Perfect. So this could be actually multiplied and written as minus 4, 5 minus y. Some of you could also write the answer as plus 4, y minus 5. Either way, both will be the correct solution. Does make sense to you, right? So that is how you could factor. Now there could be an alternate approach, and that is you could expand, further simplify, and then get. But this is probably the best way of factoring. So what you saw here is if you have seemingly different terms, think about taking negative as a common factor. If you do that, you see in this case 5 minus y and 5 minus y become a common factor. So when I take 5 minus y as a common factor along with 2, I will get 1 as the term left in the first term and 3 in the other with a negative sign. 1 minus 3 is minus 2, and therefore we'll just multiply and get a result. We could actually multiply by negative and reverse back 5 minus y as y minus 5. Perfect. This could be one of your multiple choice test question where the term given to you in a choice is this. So in that case, it could be very tricky. Perfect. Now here we are almost at the end. The last practice test question for you to factor. So you need to factor 5x minus 2y squared minus 10x plus 4y. So I'd like you to factor if possible. Perfect. Now let's do it. I hope you got the result. We have two. All right, let me write 5x first. 5x minus 2y whole square minus 10x plus 4y. Well, it looks as if it cannot be factored, but look, we could take something common here between 10 and 4. So I could write this as 5x minus 2y whole square and minus 2 is common, right? So we get 2, 5x minus 2y. Now we do get a common factor, which is 5x minus 2y. Perfect. So when 5x minus 2, 5 is a common factor, in the first term, you are left with 5x minus 2y since it's a square, and the second term with minus 2. Perfect. So we get our answer, which is 5x minus 2y times 5x minus 2y minus 2. So that is your final answer. So I hope that makes sense. So that is how we could do factoring and group factoring. So this particular video provides you with basic information, lays a good foundation for factoring. Now in the next video, we'll understand factoring trinomials, where we are going to learn the method of sum and product. And we'll also do difference of squares. And then we'll have application test questions. So with that, we are going to end this unit on common factors. I hope you understand and appreciate it. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.